All right, if you see the word and, or compound inequalities, compound means they're going to give us two inequalities and we have to graph them together. Okay, and inequalities are the intersection, which means they make both, so the solution is what makes both inequalities true. Okay, so I'll show you what that looks like. Pretty much they're going to give us two inequalities. We have to graph them on the same line, and where the colors mix or where the lines overlap is going to be our solution. All right, example 1. If they give us b is greater than -1 and b is less than or equal to 3. Immediately we see this and you're thinking, okay, and means intersection. Okay, so where they both are true. So we're going to go ahead and we're going to draw our number line, just like we've been doing. Okay, and we're going to graph just each one. So I'm going to start by graphing this one. Okay, so b is greater than -1. So I go to -1, it's an open circle, okay, and I'm pointing to the right. Straightforward. Now I'm going to graph on the same number line, b is less than or equal to 3. So I go to 3, it's a closed circle, and I'm going towards the left. So like I said before, it's the intersection. It's where they are both true. So I go ahead and I'm going to make another number line because remember, this is just your work. This one's going to be our final answer. Okay, so our final answer is this section where they both overlapped. So I go to -1, I put the open circle. I go to 3, where it's a closed circle, and then I just shade in the middle. Notice there should be no arrows because that is the only part where they intersect. That's my answer. Okay? Example 2. They could also show you like this. 2, oh wait, sorry. 4 is less than W plus 3 is less than or equal to 5. All right, so now you say to yourself, well, Ms. Beck, I don't see an and anywhere. Here's the biggie for compound inequalities. If they don't physically put the word and, okay, less than sounds like less and. So and, less than, less and. So if you see those less than signs, it is a and. So we know this is going to be an intersection. All right, now, since this one's all one big, I don't know, confusion, we're going to go ahead and split it up. So I'm going to take this part, this inequality, 4 is less than W plus 3, and then I'm going to take this inequality, W plus 3 is less than or equal to 5. Okay? I solve each one. I subtract 3. 4 minus 3 is 1. Remember, we always have to have the variable on the left, so I switch it. Over here, I subtract 3. 5 minus 3 is 2. Okay, so now I have my two solutions. Remember, we're looking for the intersection because this is a less than. I'm going to do this one first. So I go to 1. It's an open circle. Let me use a highlighter so it'll be a little bit better. Okay. And then it's pointing to the right. Next one, I go to 2. It's a closed circle. And it's pointing to the left. All right. So my solution, remember, this is just my work. Here's my solution, my graph. Okay. So my solution is where they both intersected, which should be this dark area here. So I just go ahead and rewrite it. I go to 1, it was an open circle. 2, it was a closed circle. And then where they both mixed was right in between it. Okay, next one. Let's do this one. N minus 8 is greater than or equal to 6, negative 6. And N plus 8 is less than 3. I don't know. Let's see what happens. All right, so I see that and the first thing I do when I see that and is I know it's an intersection. So it's where they're both true. So I want it where they both crisscross each other. Okay, so I'm going to take this first one over here. I add 8 to both sides. N is greater than or equal to 2. Okay, I go over here. I subtract 8 on both sides. N is less than negative 5. Okay, so now I'm going to go ahead. Negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1. Need a bigger number line. 2, 2, 3. Okay. For my red, I go to 2. It's a closed circle. And I'm headed to the right. Now I go to my blue. I go to negative 5. It's an open circle. And that is going to the left. So now I have to, so once again, this is my work. So now I need to find my solution. Remember, my solution is where they intersect each other. So now I have to ask myself, is there anywhere on that line where the blue and the green mix? I do not see it. Versus like, look in the last one. If we look in the last one, remember here, they mixed. I don't see anywhere where they crisscross or they mix. Therefore, my solution would be no solution. And it would be a bare graph. You would not do anything. Okay, let's do a couple more. Example 4. All right, let's see. Negative 10 is less than or equal to 2x, which is less than or equal to 12. Okay. We see these less than signs. Less than, less than. So less than sounds like less and, so we know it's an intersection. So we need it where they both crisscross. So I'm going to go ahead and break them up. This one's negative 10 is less than or equal to 2x. Over here, we've got 2x is less than or equal to 12. Okay, solve them both. Divide by 2, divide by 2. So x. Remember, I have to have my x on the left, so x, negative 5. Over here, divide by 2. All right, so there's my 2 solutions. Let's go ahead and graph them. 0, 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3. All right. My red one, I go to negative 5. It's a closed circle pointing to the right. Now I go to the blue. It's a closed circle. Oh, that kind of went weird, huh? Wonder why I did that. Okay. Then I go to 6. It's a closed circle, and it's going to the left. Okay. Why? What's happening? That's so weird. Okay. I don't know. For some reason, it's like, let's move both of these up a little bit. Okay. Okay, whatever. All right, so our work, or this was our work. Our solution is their intersection. So I started over here. I'm just going to put negative 5. My endpoint was 6. Okay. So I had closed dots at both of them, and they crisscrossed. So they intersected. So the solution is every single number in between negative 5 and 6. And they're both included, remember, because they are points. They are closed-in dots, okay, because that equal to. All right, so here's a couple of different things for you, different examples. Here's your practice problems, okay? So have those graphed out. Remember, I better not come in and just see this tomorrow, because that's not an answer. That is work. Your answer, you should have 2 of them, one with your work and one with your solution, okay?